Hi everyone. Today we will do a very interesting and famous interview question. Connect notes at same level. This question, was asked in Google as well. So let's understand the problem statement first. So we have given a binary tree, and we have to connect the nodes which are at the same level. For example, there are three levels, right? This is level 1, this is level 2, and this is level 3. Okay, now what we have to do is we have to connect the nodes which are at the same level. For example, C is at the right of B, right? So we have to connect these two, and E is right of D. We have to connect D with E, and F is the right of E, so we have to connect E and F as well. So now if you see in the output tree, there is no right of no right node at the right of A, right? So we'll just add the null pointer. There is nothing at the right of C, so that's again the null node. Null basically we have to add, and the same applies for the F as well. So basically last node of the level should have null at the end. Okay, so this is the question. Um, let's think now how we can solve it. Okay, so s- so if we see, you might have heard about the pre-traversal algorithms, right? Pre-order, in-order, or post-order. So let's see if that can solve the problem. So for example, pre-order traversal is root, right, and left, right? So now root of this tree is A, and right of, this is left and this is right. So now left of A is B, right? Now B is again the root of something, right? B has again left and right child. So as per the pre-order, first we will have to first root will come, then left and right. Accordingly, uh, D and E should come first, and then right of A, which is C, and then right of F. So basically, this is A is root, BD is in the left subtree, and C and F is on the right of subtree of A. Okay, but here if you see, there is we have to connect the nodes which are at same level. For example, we have to connect B and C, right? But there is a no way we can connect B and C with pre-order or in order or post order. Okay, so basically, if you notice carefully, basically each we are connecting nodes which are at same level. So basically, we can do the level order traversal of the tree. So I have covered the level order traversal in my previous video in detail. So I suggest you to check that out first and before just to understand this question better. For example, like I'll just quickly cover what level order traversal was. For example, this is my queue. Okay, the whole idea of the level order traversal was that we will pick a node. For example, we picked A, then immediately we will add the left and right of A into the left and right children of the node into the queue. For example, we started with A, and when we processed A, we immediately added left and right child of A into the queue, which is B and C. Okay, now when we'll move to the B, again we'll do the same exercise. We will process B, and we will move the we will push in queue the D and E, which are the left and right child of B, into the queue. For example, I'll add D and E into the queue, and I'll mark this as processed. And now we will move to the next node, C. We will process C, and we will add C doesn't have any left child, so but C have F as right child, right? So we will just add F into the queue and we will process C. And same for D. D we will process D, but D doesn't have any left or right child, so we'll just write D as it is. And now E again doesn't have any left or right child, so nothing should be pushed into the queue. Again, we'll process, and again F doesn't have any left or right child, so nothing should be in queue. So this is our level order traversal. Basically, if you see, right, A is at first level and B and C are at the second level, and D, E and F are the at the third level. So this is our level order traversal. Now, the change here is, so basically what we have to do is we have to mark, basically for C we for B we have to add a right pointer, that next right node is C, and same for D, like we have to mark that next node of D is E and next node of E is F. For example, this is the link which we have to create as to solve this problem. Okay, B should point the right uh, node, right node which is C, and D should point to E and E should point to F. So now if you see, so basically we are connecting it with the previous node, right? E is connected with this previous node, F is connected with its previous node, and here C is connected with its previous node. So basically to solve this problem, we have to keep track of the previous node so that we can simply update the pointer. Okay, so one thing is we have to keep track of previous node so that we can update the pointer. And second thing, if you notice carefully, is like B is also previous of A, right? And C is also previous of D. But here we should not make this link because these are at different levels. Like we should not link B with A or C with D. Instead, we have to mark the next of C as null, right? So uh, the idea is basically if the node is at next level, then we will not update the previous, but if it's the same level, we will update the previous. For example, this is level 1, this is level 1, this is 0, 1, 2, right? So we have previous. We will mark the we will update the previous only if level is same. For example, previous of B is A, okay, but level it's B is at level 1 and A is at level 0. Then we should not make this link. Basically, we will not update the previous of B. Okay. Now, if we move to C, right? C, the previous of C is B, and C and B are both at the level 1. So we will establish this link. Again for D, E, F. Okay. Let's check for D. D, previous of D is C, but there is a level difference. Okay, this is at level 1, this is at level 2, so we will not make this connection. Now let's check for D and E. Previous of D is E, previous of E is D, and D and E both are at level 2, so we will make this connection. Okay, and again same for E and F. Previous of F is E, but and both E and F are at same level, level 2, so we will make this connection. So basically we will while updating the previous, we will also check if level is same. Okay, so this is the whole idea. So let's now do a try run. Okay, now let's run through a example. For example, A is my first node. Okay, I'll add A into the queue. Let me create a new queue altogether. Just to be cleaner. I pushed A into the queue and my previous is null. Okay, because I am starting from the first node and there is no previous node. So so previous is null. Okay, now I processed A and I pushed child of A, left and right of A into the queue, which is B and C. Now I processed A, right? So previous changed from null to A. So my next node is B. Okay. So I uh, I pushed left and right of B into the queue, which are D and E. Now I am also checking whether I should update, uh, whether I should make a link between A and B or not. Okay. So now if you see previous of B is A, but B is at level 1 and A is at level 0. So we will not make this connection. We will just simply update the previous to B. So so you might be thinking how we will keep track, uh, how we will basically keep track whether it's a level 0 or 1. That part I will cover later, just 2-3 minutes later. Just to like so that first understand this thing properly. Okay, so now I have not updated the right. I have not made any created any link between A and B because level was different. Now B is processed. I'll pick C. Okay, so now my previous is B. Sorry. So now first we have to push the left and right of C into the queue. Right, C doesn't have any left child, but C have only one right child, F. I'll push that into the queue. And now while I push the F into the queue, and along with that, I will also check whether I should make the I will make create any link between B and C or not. Because my previous is B, and now I am because level of B and C is same, right? So I will create a link between B and C. Basically my previous node is B, so I'll just simply update the right pointer of B to the node C, which is my current node, because level of both was same and previous was also not null. Now I'll move to next, which is D. D doesn't have any left or right child. Sorry, when I process C, so my this previous pointer will become C. Okay, and now D doesn't have any left and right child. Nothing should be pushed into the queue, but C and now I'll check whether C's right pointer should be updated to D or not. No, right, because C is at level 1 and D is at level 2. So there should not be any connection. But my pointer will be updated, previous pointer will be updated to my last processed node, which is D. Okay, now I'll move to next node, which is E. Okay, so now E also doesn't have any left or right child, but level of my previous level of D and E is same, so I should make link between D and E. Okay, so now my previous node is E, and now I'll just mark this processed, and now next node is F. So level of E and F is same, so I will simply update the right pointer of E to point to F. Okay, so this is how we will be doing it. So let me also show you the code Uh, so one thing is pending is how you will basically keep track of level, and previous we have already covered, right? Let me show the code. Okay, so now if you see, right, we are using a queue to queue the left and right element. So I just declared a queue, and we are starting from the root element. So I just added a root into the queue, a root node into the queue, and um, basically, if you see, right, when I was doing this manually, I was doing the same thing again and again till my queue was empty, right? So same condition is I added in the queue. I'll do the repeat the same steps till my queue becomes empty. And again, I'm fetching the size of the queue, and I have a for loop here. What does it mean is, so these are two nodes, right? And these are three nodes. Now we have to we will not update the previous pointer. Basically, we will not create this pointer if level is different. Okay, so whenever we are picking any, so let's understand this. So these are two elements. So loop will run because here we are saying that so when we processed a, right, when we processed a, we added two right, left and right of a into the queue, and we removed this queue because we use queue dot poll, right? So when we removed queue at that time, there were two elements in the queue. So my next loop will run I equal to 0, I less than 2. Basically, I will run two times for B and C. Values of I will be 0 and 1. And for D, E, F, loop will run three times 0, 1, and 2. Now, if you notice, right, and for A, loop will run one time for I equal to 0 only. This, so basically, so if you notice, so whenever I becomes 0, right, whenever loop runs for I 0, we should not update the previous, basically we should not update the previous pointer. So in this case, if you see, right, if I is 0, that means we are at B and we should not update the previous pointer because we know that whenever loop starts, that will be altogether a new level. And here if you see for D, right, when this loop for loop will run thrice, three times I 0, 1, 2, and whenever I will be 0, so basically for D, whenever if I is 0, we will be at D and we should not care about the previous pointer, which will anyway point to C. So we will just ignore. So that's this condition. So int n q dot size. So when we pushed A, size of Q will be 1, right? So I equal to 1, this loop will run once. We will just save the previous node. Previous will be, when we are at A, right? Previous will be null because that's the first node and there is nothing previous, nothing before A. And now we will delete Q dot poll, basically delete, remove, returns the front node of the queue, and it basically removes that node from the queue. Queue dot poll. So we have A now, and when we did queue dot poll, my queue became empty. Now I'm checking if I greater than 0. So for we are at A and this loop queue size is 1, right, at that time. I 0, I less than 1 because Q has only one element which is A, and now I am checking if I greater than 0. So loop is running from, loop is starting from I 0, right? So now it will basically I is not 0, because this is the first element, so we will just ignore, we will not update the previous pointer. Instead, we will push the left and right into the queue if that are not null. For example, left and right of A, R, B, and C, we will just push that into the queue. Now, queue have two elements, B and C. B and C. Now, N will be 2. Queue size will be 2. Okay. Now, my previous is A. Previous equal to node. Node was last processed node was A. So, my previous here is A. And I'm checking if I greater than 0. I is we are n is 2, we will run loop twice, right? I 0 1. I 0 which means we will ignore I 0 means we are checking for B, and we will just simply ignore the previous pointer and we'll push the left and right of B into the queue. And now loop will run again for I equal to 1. Now I equal to 1 will be my C, and for C, I is 1, 1 greater than 0, definitely. So we will just update the uh, uh, previous node is my B, right? So we will update the next right of B to the current node, which is C. And again, we will push the any left or right child of C into the queue, and we'll do the same exercise. So that's all. That's the idea. Basically, on we will just we have to keep track of two things: previous and level. And level, just we are keeping track of from I value of I. If it's 0, then that means a new level is starting, and we'll just ignore the previous pointer. Okay. So now coming to the complexity. So if you see, right, we are using a level order traversal algorithm here. So level order traversal means basically when you are traversing something, right, basically we are you are displaying each and every node of the tree. If there are n nodes, you will print the n nodes, and if there are like for example, if there are 5 nodes in the tree, you will print all 5 nodes, and the complexity will be big O of 5, because so complexity is basically equals to the complexity is basically the number of times you are touching the nodes. So you are printing n nodes, so complexity will be as simple, like it will be big O of n. And now you are using this extra memory, right, for the queue uh, to keep track to store the left and right pointers. So that will be ON will be the your space complexity. That's all. And I have also pushed this code into my GitHub account. So I'll just add this link into the video description. Please check this out. And if you have any question, um, just comment on the video. I'll try to reply. And if you liked my video, please give thumbs up. And if you want to see videos like whenever I post something new, just click on subscribe button. Thank you so much.